Hello, my name is Aaron. I'm responsible for the software here at TCI, and today I want to give you a short update about our development of the Inertial Navigation System, or INS. You would say that this in front of me is a rocket, and you're of course right. This is a game hub from a different project, but it has two components which are needed for orientation tracking. A processor, in this case an ESP32, which is able to do the math, and when you look up there, there's like a small blue PCB. That's an IMU, or inertial measurement unit. In our case it's an MPU 9250, which has 9 degrees of freedom, so 3 for acceleration, 3 for angular rate with gyros, and 3 for magnetometers. In this first demo we will focus on this gyros and integrate them over time, and let me pull that up. Okay, so on your screen you can see this up arrow, as I call it. So imagine that out of there sticks like this arrow which points upwards, and it moves along as I rotate this device. So when I move it that way, it moves with me, and when I move it that way, it moves with me as well. I'll put that down, and there you can see that this follows along my lead quite nicely. So here downwards, and the important part is when I turn it back up and sit it down, this up arrow is more or less straight up. But there still is a problem, because when the vehicle, or in this case the game hub, starts at this angle, the gyros will integrate from that, and so you will have an offset between the measured values and the real values. So our approach to that is to assume that the vehicle is not moving in the beginning, and then to calculate the initial angle with the acceleration, because gravity points downwards on Earth, and so we calculate the quaternion we need to rotate our acceleration around that it points downwards. As you can see on the screen, this arrow is at an angle as the devices, and when I pull it down, it is again more or less upwards. But there is one major problem left with orientation tracking, because gyros drift over time. So when you look at the screen, you can see an upsped footage of this plotting of the up arrow, and you say that it moves, but I'm not moving the device. So this is the so-called drift. To fight that, you can implement a filtering algorithm. We are currently working on that, and that will be our last third of this orientation tracking. More on that in our final high quality video about this first development of the INS. Of course, this is only the first step. We can imagine that we will do many more things with the INS, because it will be such a core system of our rocket one day. If you liked what you saw today, please follow along here at this website, or at our social media, or at YouTube. We are currently in the works of our first video, which is more or less an introduction to ourselves. We hope that will drop in the next month or so, and then after that this first part of our INS development will be produced and uploaded. So stay tuned, bye.